Hey guys, welcome back to the second part of my video on straight lines. Today I'm going to run you through all the common styles of exam question that come up. This is going to include the equation of a straight line through 2 points, the equation for a perpendicular straight line, the equation for a parallel straight line, finding a midpoint between 2 points, the distance between 2 points in the plane, and some geometry problems in the plane. We're going to be using all the concepts I talked about in part 1 of this video, so if you haven't watched that already, you can find that in the description. Let's get started. So for question 1, it says we have the point A and the point B with coordinates 11, 2 and -1, -1 respectively, and the first thing is, can we find the gradient of the line that goes between these 2 points? So first we have to just remember the equation for the gradient, which is going to be y2 minus y1 over x2 minus x1. And if I call this point 2 and this point 1, then we're going to have -1 minus 2 over -1 minus 11, which would be -3 over -12, which would be 3/12, and 3/12 is a quarter. Part 2 then says, hence or otherwise show that the line AB has the equation of that form. Well, for part 2 then, if that's part 1, part 2, we know already that the equation must have the form y equals a quarter x plus c, and to find the c we can just simply sub in any of the points A or B as they're going to lie on the line. So let's pick -1, -1. So subbing that in, we'd have -1 would equal a quarter of -1 plus c. So to find c then, we're going to have -1 plus a quarter, which would be -3/4. So that means the equation of our line is y equals a quarter x minus 3/4, and then we just have to move it around into that form that's given there. So first I'm going to multiply everything by 4. So then we'd have 4y equals x minus 3. And then if I move around the x and y's, we would get the final result of x minus 4y equals 3. The next question asks, the line AB has the equation 3x plus 5y equals 8, and the point A has coordinates 6 minus 2. Can we find the gradient of AB? So that's just using the equation that we've already been given. So let's just write it down first. And we need to write it in the form y equals mx plus c, because m would be our gradient. So let's just rearrange for y basically. So 5y would be minus 3x plus 8. So then y would equal minus 3/5 of x plus 8/5. So that would mean the gradient of our line for AB is minus 3/5. Then it says, hence find an equation of a straight line which is perpendicular to AB and which passes through A. Well, to get a perpendicular straight line, we know the gradient is going to have to be the negative reciprocal. So the gradient of our line is going to be -1 over minus 3/5, which would just be 5/3. So the equation of our line is going to have the form of y equals 5/3 x plus c. And if we'd like it to pass through the point A, then we can just simply plug in the point A of 6 minus 2. So plugging that in, we'd have -2 equals 5/3 times 6 plus c. Simplifying that down quickly, we'd have -2 would equal 6 divided by 3 is 2, and then 5 times 2 is 10, so that's 10 plus c. So c then is -12. Meaning that we'd have y equals 5/3 x minus 12. For the next question, it says we have a triangle ABC and we're given the coordinates of all the vertices. And can we first find the midpoint between B and C? So to find a midpoint, you have to remember we add up the coordinates and just average them. So for part A, that's just going to be 4 plus 2 divided by 2, and then 1 minus 5 divided by 2, which is then going to be 6/2, so 3. Then we have minus 4/2, which would be minus 2. Okay, and then for part B, it says, can we find the gradient for AB? That's just using the gradient formula, so we'd have, for part 1, by2 minus y1 over x2 minus x1. So let's say this is 0.2 and this is 0.1. We'd have 1 minus 3 over 4 minus 2, which would be minus 2 over 6, which is simply minus 1/3. Then for part 2, it says, hence find an equation for the line AB, giving your answer in the form x plus qy equals r, where q and r are integers. So we need to just find the actual equation now. We already have the gradient, so we know y equals minus 1/3 x plus c. And we can sub in either point A or B, because we know those are going to lie in a line. I'm going to pick point B. So let's use 0.41. So that's going to give us 1 equals minus 1/3 times 4 plus c. So then c is going to be 1 plus 4/3, which is just going to be 7/3. So then we have y equals minus 1/3 x plus 7/3. But we're not quite done, because it's asked for there to be no fractions, essentially. These coefficients, q and r, need to be integers. So let's fix that just by multiplying everything by 3. So then we'd have 3y equals minus x plus 7. And now all we have to do is rearrange. So we'd have x plus 3y equals 7. And then for part 3, it says find an equation of the line passing through C, which is parallel to AB. So if it's parallel to AB, it's going to have the same gradient of minus 1/3, but it's going to have a different constant, which we can find just by plugging in a point that will actually make it pass through C. So plugging in C, essentially. So we're just going to repeat the process we just did again, basically. So we know y equals minus 1/3 x plus c. And we're going to use the 0.2 minus 5 to find our different value for c. So we'd have minus 5 equals minus 1/3 times 2 plus c. So that's going to be minus 5 plus 2/3, which is going to be minus 13/3. So c is minus 13/3. So then we have y equals minus 1/3 x minus 13/3. And it hasn't asked us to leave that in a specific form, so we can just leave that as is. Next up it says, prove that angle ABC is a right angle. So just to be clear about what that means, so this is part C now. ABC means we'd have A here, B here perhaps, and C here. So the angle ABC would be the angle at the vertex B. And if that's a right angle there, then we know the gradient of AB must be perpendicular to BC. So we already had the gradient of AB earlier to be minus 1/3. So now we just need to find the gradient of BC so we can check to see if they actually are perpendicular. So using the points B and C, so these 2 points here, we've got -5, -1. This is the gradient of BC, which would be -5, -1 on the top, and then 2 -4 on the bottom, which would be -6 over -2, which is just 3, which is the negative reciprocal of these. So we know that that must be a right angle, because if we multiply the gradients together, we would get -1. Okay, then next up we've got the line L1 passes through the point A with coordinates 2, 5 and has gradient -1/2. So we just need to find the equation for that in part A. So that's going to mean that y is -1/2x plus c, and then to find c we can just plug in the point. So that would give us 5 equals -1/2 times 2 plus c, which is going to, c is just going to be 5 plus 1, which is 6. So we have y equals -1/2x plus 6. Okay, and now for part B, it says the point B has coordinates -2, 7. Can we show that that lies on B? Well, we can verify that lies on B just by subbing in one of the coordinates and seeing that the other one checks out. So I'll plug in -2, say, and we're expecting to get y to be 7. So then we'd have y equals -1/2 times -2 plus 6. -1/2 times -2 would be 1. 1 plus 6 does indeed give us 7. Okay, now part C says, can we find the length of AB, giving your answer in the form k root 5, where k is an integer. So to start that, we're just going to use the distance formula. So distance is the square root of the difference in the x's squared plus the difference in the y's squared. And then if we say point 2 is point B and point 1 is point A, then we're going to have the square root of -2 squared plus 7 5 squared, which is the square root of -4 squared, which is 16, plus 7 5 squared is 2 squared, which is 4. So that's 4, so that's root 20. And we can take a factor of 4 out of 20, which would give us 4 times 5. The square root of 4 is just 2, so that's just 2 root 5. So our k that they asked us for is 2. Okay, and now for part D, it says the point C lies on L1 and has x coordinate equal to p, and the distance between C and A is 5 units. And using that, can we show this result here? So there's 2 pieces of information here. We've got this and this, and let's just be clear about what this means. If C lies on L1, then we could find the y coordinate of the y coordinate of C in terms of p by using the equation, which is just this one here. So let's do that first. So y equals -1/2x plus 6, and we were told the x coordinate of our point C was p, so plugging that in, we have y equals -1/2 p plus 6. So our point C is p and then -1/2 p plus 6. And then we know that the distance between A and C is 5 units. So our point A was 2, 5. So if we use our distance formula, which was the square root of x2 minus x1 squared plus y2 minus y1 squared, with these 2 points, we know that distance needs to come out as 5. So we'd have 5 would equal the square root of 2 minus p all squared plus 5 minus, and then we got two terms here, so whenever I subtract two terms at the same time, I'll put them in a bracket just to make sure I don't make a mistake with any double minus signs. So minus a half p plus 6, and close the big bracket, all squared. And now we just have to start tidying this up, and we should get the result they asked for. So first thing is I will square both sides to get rid of this square root. So 5 squared is 25, which is going to leave us with a 2 minus p squared, and now, plus, and then if we just tidy this up inside here a bit as well, so we'd have 5 minus 6, that would be minus 1, and then we'd wind up having actually a double minus on there, so it'd be plus a half p. That's all squared, and now we need to start expanding the brackets, so we'd have 25 would equal 2 times 2 is 4. We're going to have two lots of 2 times minus p, so that would be minus 4p in the end. And then minus p squared would be plus p squared. Then we have minus 1 times minus 1, that's going to be plus 1. We're going to have two lots of minus 1 times a half p, so that would just be minus p. And then a half p squared would just be a quarter p squared. And now we just have to start collecting our terms. So p squared plus a quarter p squared, that would be 5 quarters p squared. Then we've got minus 4p minus p, that's minus 5p. And then over here we've got 4 plus 1, which is 5, but we've got to take away 25 from that, so it's going to be minus 20, which will all be equal to 0. And then we can simplify this down. We can first divide everything by 5. So we'd have a quarter p squared minus p minus 4 would equal 0. And then to finish off, we can multiply everything by 4. So that would leave us with p squared minus 4p minus 16 would equal 0, which was the final result that they asked for. Okay, and now for our last question, we've got the line AB has equation 4x minus 5 and passes through the point B with coordinates 2, 3. The line BC is perpendicular to AB and cuts the x-axis at C. Find the equation of the line BC and the x-coordinate of C. Well, first off, if we know the gradient of AB, we can work out the gradient of BC by the fact that they're perpendicular. So if the gradient of AB is 4, then the gradient of BC must be the negative reciprocal of that, which would be minus a quarter. And then to find the equation for BC, well, we already know it must be in the form of y equals minus a quarter x plus c. And to find our c, we can sub in the point B, which we know to lie on the line. So plugging in the point 2, 3, we'd have 3 equals minus a quarter times 2 plus c. So that minus a quarter times 2 is just minus a half. And then 3 plus a half would be 7 over 2. So c is 7 over 2. So that means the equation of our line would be y equals minus a quarter x plus 7 over 2. And now we just have to find the the coordinate for point C, which is where our line intersects the x-axis. So that's when the y-coordinate is 0. Any point along the x-axis is where the y-coordinate will be 0. So if we set y to 0, we'd have 0 equals minus a quarter x plus 7 over 2. So then we'd have a quarter x would equal 7 over 2. And then x would be 7 over 2 times 4, which would just be 14. That's the end of the video, guys. I hope you found it helpful. If you did find it helpful, please like the video. That helps me out a lot. and consider subscribing to the channel to stay tuned when I release more videos. Thanks, and I'll see you in the next one.